All right. By popular demand, we got a lot of requests to have our next speaker, researcher and author Lloyd Pye, who will be talking about an unusual skull found in Mexico in the 1930s. But in order for him to get all the information on, please help me welcome Lloyd Pye.
Thank you. Thank you. All right, everybody in? No, everybody's not in. First slide up. Uh-oh. Oh, wrong. Which one do you look at? I thought they were both the same. All right. Many of you know me from before. I've been here a number of times at Laughlin, but a lot of you will not. Today is going to be a very special presentation. I've thrown this together in 3.5 days since the weekend. You'll find out why as it goes along, but it's going to be a very special experience for you here today. And I'm very happy to be able to share it with you. I want to start off with a bit of history because this is what the lecture is going to be about, history. This is the August 2nd, 1939 letter from Albert Einstein to Franklin Delano Roosevelt in which he began to put forth the idea that atomic energy could create massive superweapons and that the Germans might get one first if the Americans didn't do it. 6 years later, July 16th, 1945, the first atomic bomb was exploded. 3 weeks later, August 6, 1945, Hiroshima was destroyed and the post-war era began. May 25th, 1961, President Kennedy announces a national goal of safely landing Americans on the moon by the end of the 1960s. 8 years later, July 20th, 1969, Apollo 11 begins the space age. Yes, I know some people think it didn't happen, but I'm confident that it did. August 1st, 1969, Xerox creates the Palo Alto Research Center, PARC, for creating new office systems, especially new copying machines. Out of that, 4 years later, May 1973, the first working model of an Alto computer begins the computer age. Can you give me a second? Guys, these slides are a little twisted on the screen out here. I don't know how it is with you. The upper right-hand corner is a little high. El Paso, Texas, February 18th, 1999. Ray and Melanie Young introduced Lloyd Pye to the Star Child skull. Now, where are Ray and Melanie? I know they're here. I can't see with these lights. That's Ray and Melanie right there. They're the owners of the Star Child skull, and they're the ones who gave me the job to do something with it. And I told them the night that we met, I said, well, it looks like it'll take maybe, because it's so exciting and so different, I think it'll be 6 months max, and we'll have some answers. And here we are 12 years later, almost to the day. Almost to the day. Now, 12 years later, February 24th, 2011, at the UFO Congress in Scottsdale, Arizona, the post-disclosure age begins. Now, I know that sounds over the top, but miracles do happen. And I want to share a couple of miracles with you real quickly. Last Friday night, February 18th, 12 years to the day when Ray and Melanie presented me with the Star Child skull for the first time, I was at the home of our geneticist, and he was in the process of tearing my head off with the new results that he had, which I'm going to share with you today. 12 years to the day from when I see it, I get what is essentially the proof that we've been looking for the whole 12 years. That's a miracle. Also, another miracle is that when Ray and Melanie showed that to me, I was on my way here to this event, to the UFO Congress in Laughlin of 1999. And I, at that time, didn't know anything about UFOs or aliens. I was a hominoid and a human origins researcher. And so I said to them, well, I'm on my way to this conference and there will be a lot of experts about UFOs there, and could we just take the skulls and show it to them and get better input on what they might be. And I came, and all everybody told me pretty much was, boy, you're dead. The government's going to come get this and kill you, and it scared the poop out of me. They did, because I didn't know any better. I didn't know any better. But I have to say that Bob and Terry Brown, who were in charge then, were wonderful. They just took me in like, some kind of wayward child, and they said, we'll take care of it, don't worry. And they got people around, and we all evaluated it, and we took it for its first round of testing. And so at the end of that week, which in this time is going to be Sunday, on Sunday, the night of what would be Sunday, but it was a Saturday night then, I gave a little presentation about the Star Child. Within a week of laying eyes on it, I gave a presentation showing it to everybody and telling them everything we knew. And here I am 12 years later introducing the proof of that, those speculations at first, to you. Another small miracle. Unfortunately, before we get to the miracle, I have to do 3 important sidetracks. It won't take long, but they're all important. Bear with me, please. Many of you know that Zecharia Sitchin died late last year. In his last book, There Were Giants Upon the Earth, he closes the book with a plea to have the DNA of the Queen Shubad Puabi, whose body is held at the Museum of History in London, to have her DNA tested, because it was his belief that she was directly descended from a goddess. Directly descended from a goddess, which means that her mitochondrial DNA will be the DNA of her mother's line. So it should be Anunnaki DNA if he's right in his theory, and I think that he probably is. So when I did 3 tours and 3 trips to Europe last year, and the last one, I went by to visit with Dr. Margaret Clegg, who is the woman that he dealt with. And she told me what they have to go through, the process that the Sitchin Foundation has to go through. And I asked John Cogswell, the guy who's in charge of that, one of Zechariah's best friends and a lawyer, and he wrote back to me, "It is my understanding that Dr. Eske Willerslev of Copenhagen University in Denmark has agreed to sequence Puabi's mitochondrial DNA, and he is in the process of getting in touch with Margaret Clegg at the British Museum. The Sitchin family has been in touch with Dr. Willerslev, but the Sitchin Foundation has to be established through probate. And the foundation will sponsor this effort. I will keep you informed of everything as I learn." So it's underway. It's just going to take time. Many of you have emailed me asking, what can be done? What can I do? I've done all I can do at the moment. So it's underway. The next thing I want to share with you is a man named John Jensen from Apopka, Florida, got in touch with me recently. And he wanted to share with me some new research that he's done that I think is amazing. I've been to his house and I've seen it. His work provides convincing evidence that along much of North America's eastern and southern coastlines, an extremely numerous, highly advanced civilization existed about 7,000 years ago, 5,000 BC. This high culture, which may have equaled our own, was wiped out in a catastrophe that left visible only the deep marks they dug into the Earth's surface, much of which is now submerged to a depth of 3 to 5 feet. How can this be possible? Because for thousands of years it has been right under our noses, hiding in plain sight. I thought that when the sea rise since the end of the last ice age, the 300 feet, I assumed it was a curve like you see here, just the kind of gradual curve. It wasn't that way. It was done in a series of jumps and fits and starts. So when you look at what really happened, you see that up to 7,000 years ago, it was fairly steady, and then suddenly it stops, and from 7,000 years ago, there's only been 5 feet of rise. Since 5,800 years ago, there's been 3 feet, and since 5,000 years ago, there's only been 1 foot of rise. Something happened around 7,000 years ago to change things. We don't really know what. Now, what you see with John's work is it's strictly Google Earth, but he has a super duper Google Earth thing, and you can really see clear. This is terrible by comparison. I'm almost ashamed to show you, but it's all he really can do when you get it. But all of this is, there's canal systems here. This is a harbor, and a big harbor. And these canals all curved through here, and that little bump that you see where the houses go in, you can see people can wade right out in that. That used to be part of the harbor. And all these canals are not really, they're not new. The people just build on what was already there. It's amazing, and there's lots of it. Up and down the East Coast, around Florida, and over to Louisiana. Now, Louisiana is where the action really is. And I'm from Louisiana. That's how he got me. He said, "You're from Louisiana. How do you not know about this?" I said, "I always heard the oil companies dug them. They didn't dig them all. Look at these double tracks. This goes for 100 miles across the south of Louisiana and north and south. These big double-tracked canals go, and here you see on an island out in the middle, you see how they are, and they're partially submerged. Oil companies didn't dig that. Didn't dig that. The sea levels haven't risen but a few inches since the oil companies started working down there in the 20s and 30s. These are ancient, folks, ancient. That's why he calls them ancient canals. Here you see a good look at one of them, and there's the midline that really exists through all of it. It is the largest mega engineering job on earth ever. Bigger than the Panama Canal, bigger than the Suez Canal, all of them put together 7,000 years ago. This is history in the making, folks. If anybody wants to get involved in it, help him out, send him some money. He needs to do all kinds of research. John Jensen of Popka, Florida. His website is ancientcanalbuilders.com. ancientcanalbuilders.com. Last thing, the last sidetrack is Inside Blood is a magazine, a specialty magazine. It sounds a terrible title, but for those who care, it's important. 15 November 2003, volume 102, number 10 pages, Fetal microchimerism, what our children leave behind. This is very important to our field. Fetal microchimerism describes the persistence of low numbers of fetal cells in any mother after pregnancy. FMC has been found to persist for up to 38 years after a pregnancy. Adams and colleagues evaluated female hematopoietic cells, transplant donors, for the presence of Y chromosomes, specific DNA. Strikingly, Y chromosome DNA, which comes from fathers, could be detected in more than 1/3 of peripheral blood stem cell collections and in nearly 1/2 of the CD34 selected cell fractions from these female donors. Meaning when you have a baby with a man, his DNA, some of it stays, the baby's rather, and the father's stays in your blood. So, our geneticist feels that at some point in the future he could analyze blood samples from volunteers to determine if alien markers can be isolated. If you feel you might qualify or know anyone who does, we would like to create a list of names or pseudonyms, if you prefer, to participate when the time comes. If you're interested or you know somebody that might be, get in touch with me, LloydPie.com, and I will start the process of collecting a database for that. We think this is important relative to the star child as well. Okay? Now, with all that out of the way, let's dance with the one that brung us. Adult female skull and star child skull, same size. There are 25 major physical differences between these two skulls. I do not have time today to go, my usual presentation is to go over and chronicle those 25 differences so you can see how amazing they are. I'm just going to have to buzz through them today because of the other stuff I have to tell you. If you want to know more, there is an ebook. Go to thestarchildproject.com, and there's an ebook that has all of the technical material covered extremely well with photographs and illustrations. For the paper book of the backstory, go to amazon.com. Now, today, because of this group, I brought with me, because of the weight restrictions, I was able to bring 12 of the last 20 of the 2,000 copies that were made of the first edition hardback. They're more expensive than the average book, but I promise you that if you get one, in 2 or 3 years, you'll be able to sell it on eBay for a few $100s. It's going to become a collector's item, guaranteed. Guaranteed. Those are going to be right outside this door when I finish. I'm going to go right out there. I will have those books. I also have some of the t-shirts the Star Child's t-shirts that Ray and Melanie are wearing. That's theirs. They had to do those for the Roswell 207 60th year anniversary, they asked them to do it, so they have some of those left to go. And, excuse me, and the stereolithographic copies of the Star Child skull and a human skull will be out there for you to see if you want to see that. So there's going to be some action out at the table when this is over with. Now, here's just looking at the physical differences. The jaw is too big for its face, a side-by-side comparison. Profile, the missing inion is the main thing here. The thing we all have, this knot we all have in the back of the lower back part of our head, you can feel your own. Every primate has that. If you've got a head sitting on the neck, you have one, except for the Star Child, which does not have one. It has a dent where it should have an inion, completely backwards. Very, very different. See that crease, that dent at the top of the head? That's how Grazer described having that dent in a heart-shaped face. Neck sizes are different. The human Star Child's neck is about half the size of a normal human neck. The zygomatic arches, the cheekbones, you can see what a thin, narrow face it has relative to ours. The balance points, completely different, just totally different. This slide indicates that the Star Child has a completely different brain than a human brain. It's made of a different material, a much firmer material. The chewing muscles, Star Childs are half the size of a human. The sinuses, you see the sinuses to the left of the human, the eye sockets, and then the sinuses here. The Star Child does not even have a smidgen, not the slightest trace of sinuses. Very, very unusual. By the way, that was the first test we had when I was here 12 years ago, and the guy that saw it said, "Whoa, that's weird." That kind of got us going. The Star Child's inner ears are twice the size of normal human inner ears. Its teeth are chipped, crazed, and have heavy roots. Therefore, it is not of a child. It isn't a child. We named it that. Terry Brown, in fact, named it that, and it just, it stuck. We thought it was a child at first. We were wrong. This is important. The exterior surfaces of the bone of the human on the left, Star Child on the right. Those little pits you see are called lacunae. They are essential to bone growth and full regeneration. You know how your body changes out every 7 years? The bone, some of this is sucking bone in to recycle it, and others of these are pushing bone out. It's gone on the Star Child. If you're a deformity, what are you losing that stuff for? The cuts in the skull for testing, the Star Child on the left, the human on the right. Star Child is half as thick, weighs half as much, yet is 2 to 3 times harder to cut. Recently, just within the last few months, for the first time in those 12 years, I've seen a lot of other people cut that bone. I cut it for myself. You would not believe it. You see, you look at the thicknesses right here. I took the same saw, same everything. Took me about 50 slices to get through here at the same exact depth here, about 200. It's like cutting metal almost. It's amazing. Human bone is on the left, Star Child bone is on the right. The biochemical differences are obvious. Normal bone is on the left, tooth enamel is on the right. That's why it's so hard. The Star Child bone is more like tooth enamel than bone. Again, all these details in great depth in the e-book and in the book. Two things in the Star Child skull are not found in any other creature on Earth. Unknown fibers are embedded in the matrix of its bone. Unknown red residue is in its cancellous holes. Understand, not found on any other living thing that is known. These fibers woven through the matrix of the bone. The knot and the threads. Now you see that the fibers are woven into the matrix. That's bedded in that matrix, and it got somehow, we have no idea how this happened because it was a Dremel blade cutting through. It's like the Dremel blade decided to wrap it up or something. We don't know how it happened. But nonetheless, and here you see a different kind. These fibers baffle everyone, and we've never had the money to do the kind of detailed research that needs to be done. They're very microscopic in size. No, they're not Morgellons fibers, not visible even close with the human eye, but they're there and they're very, very amazing. This is an isolated flat fiber snagged on the surface, and you see the sheared end shows that a Dremel blade, which would cut my arm off like it was a stick of butter, and that's what those fibers resisted. Very, very durable fibers. That's part of why the skull is so hard to cut. Here's a fiber embedded in the underside surface of the bone. You know, scientists a lot try to say, oh, well, that's just stuff that grew on its mold or fungus or bacteria. We took it to mycologists right away, and they said, no, nothing, that's not something that grew. That's in there. We don't know what it is, but it didn't grow. We've got everything going for us here except scientific cooperation. This is the adult female polished surfaces of human bone. This is what it looks like. It looks like alabaster. It's really pretty, really. They're clean as a whistle because when you die, bacteria clean your bones out. Absolutely everything, this is how it is. Nothing's left behind. But with the Star Child, ironically enough, you do have some red residue and quite a bit of it. How does science explain these things? It was cradle-boarded, it suffered from hydrocephaly, it suffered from progeria. Please go to the website, starchildproject.com, if you don't want to get the books, but read them. We answer all of these. You see all these bandied about on Wikipedia and other places, but all of it is, they're easy, good answers for all of it. I wish I had time to go through all that. This is forensic sculptor Bill Nunn's clay model of the Star Child in life. Now, when Bill was doing this, he's very respected. I had a couple of problems with it. I said, Bill, the eyes, they don't look right. He says, yeah, we couldn't get human eyes that fit in there. And I said, they should be like frog eyes. And he said, yeah, well, we couldn't do that. We had to reshape them and to make them look halfway human. And the neck looks too big, too. And I said, why'd you flare the neck out like that? He said, well, it didn't look right with it, anyway. They just have the human templates to go with, and it's kind of hard to create an alien. But this is the closest thing I think that we have. This was going, oh, look, it's working. Hallelujah, it's working. The guy, we couldn't make it work in the back. You see how it is? We couldn't make it work. I don't know. They must have performed some magic back there. Isn't that cool? I love that. I love that. All right. None of what you've just seen, none of the Star Child's physical differences mean anything to mainstream scientists. They explain them all away with a brazen excuse. Nature can do anything. In the world of science, nature is the equivalent of God. Nature can do anything. Any question you throw at them that they can't handle, nature. It's the perfect excuse. Only DNA impresses mainstream scientists because DNA is the math of biology. Like 2 + 2 = 4. DNA says what it says every time with undeniable precision. If we make our case with DNA analysis, we will win, and we can make our case with DNA. Now, I'm going to start slowing down, and you're going to have to put your thinking caps on now because you're going to have to learn some things in order to have this make sense. All right? Everything about the Star Child skull comes down to its DNA. The way it works is you have in all the cells of your body, except red blood cells, don't worry about it, the trillions of cells of your body, you have in here, each one, you have a nucleus, and you have floating outside the nucleus cytoplasm, and then you have the cell wall. Outside in the cytoplasm is the mitochondrial DNA. We'll talk about that in a minute. And then inside are the chromosomes, the 23 from each parent to give us our 46. 23 from each parent to give us our 46. Each of those is made up of genes. So the way it works is the genes are made up of these things here that are called nucleotides. There are 4 of those. You're going to see those in a minute. And they make up base pairs. Each of this where the 2 connect are called base pairs. You're going to see more of that. Here we go. Each base pair is 2 nucleotides, and base pairs are arrayed in genes. And they are thymine, adenine, guanine, and cytosine. Those are the 4 nucleotides that make up everything. They are the fundamental building blocks of life, and they combine together, always the same 2, to make base pairs, which make up the genes, which make up the chromosomes, which make up you, make up the cells and make up you. All right? But now we're talking about the lowest common denominator, the nucleotides and the base pairs. This is where the genetic battle is won or lost. Now, nuclear DNA and mitochondrial DNA. Just what I said in the cell, you have the nucleus and then you have the cytoplasm. Floating in the cytoplasm are the mitochondria. Inside the nucleus is all of the chromosomes from mom and dad. So mom and dad produce the whole genome. That's a word you're going to hear a lot. The genome is both of your parents' chromosomal package. The mitochondrial DNA comes down strictly from the mother, and it's very different than this. This is made up of those long strings. Mitochondrial DNA is circles. They think it might have been bacteria at one time. I don't really know, but it's very different, and it's very well conserved, and there are very few mutations in it, so they're able to study it very carefully and clock the fact that we, in terms of our DNA, are only about 200,000 years old. ironically, just about the same length of time that the Anunnaki supposedly claimed that they created us. But that's for another lecture. This is DNA arrayed in a gel sheet. You've all seen CSI, you've all seen this. I just want to show you again because you're going to see some different ones in a moment, but this is how it looks. Now, we knew from the beginning, well, not from the beginning, but from the end of 99 that we had to get the answer from DNA. So we were desperate in 99. I took a gamble. A friend said, well, there's a forensics lab up here in Vancouver. They're not equipped to do ancient DNA. The star child is 900 years old. 900 years old. Ancient DNA qualifies at 50 years. Anything older than 50 years is considered ancient. Anything less, it's a lot easier to recover. All right? So 900 years old is old, and it's going to require some very special techniques to recover it. The Bold Lab said, we think we can do it. If it was buried in a mine tunnel for 900 years, we think that we'll be able to get you an answer, and I have to say, get you an answer that you can count on, at least as far as the nuclear DNA goes, not the mitochondrial DNA. We don't have that capacity. So I said, okay, take a chance. And what came out of that was, in the end, after a customary number of PCR cycles, 28, there was a very weak 200 picograms gender profile from the second bone sample taken from the child's mastoid process. The result is XY chromosomes, which tells us two significant things. First, the child was male. Second, the DNA is human. Now, the 200 picograms. 1,000 picograms is usually the minimum threshold at which a reliable reading for forensic DNA can be made. These guys sandbagged me. What happened was it had been there for, this was the third attempt. They ultimately had to do a fourth attempt. They were catching all kinds, as I understand it, somebody told me this in private, they were catching all kinds of heat from other professors on the campus for fooling around with an alien. You can't be fooling around with an alien. So they kind of just did it to get rid of us. They were not doing well. Students, it was a student-run lab. They were contaminating everything, and they contaminated this too. Now, if they were going to lie to me, I don't know why they didn't just bump it up to 2,000 instead of 200. But nonetheless, this is what I got. And that word went out everywhere. And I just was, as we say down home, screwed, blued, and tattooed. There wasn't anything I could do. For the years 2000, 2001, 2003, the DNA coils just squeezed tighter and tighter and tighter. Nothing to do. Nobody wanted to have anything to do with it. Nobody wanted to listen. Wherever I'd go, they'd say, well, didn't that lab prove that it was a human male? And, you know, but I knew it was wrong, but I couldn't get anybody to listen to me. And because it was the answer that science wanted, science really pushed it hard, and they corked me back up in a bottle pretty much. But then, one of those miracles do happen. When at the end of 2002, my girlfriend at the time said, you got to quit this. You're $50,000 in debt over this. You're going bankrupt. And I did ultimately go bankrupt. You've just got to quit. It's making you crazy. And so I sent out word that I was quitting at the end of 2002 and early part of 2003. A woman named Belinda McKenzie in London. Many people here, actually not many, but a few people here have stayed with her. She's like a mother hen for anybody in the alternative community that washes up in London. She'll find a place for you to sleep. She's great. And at the time, she had some money. She's given it away all the way to these causes now, but at the time she had a little money, and she said, what would your test cost? And I didn't know, but I looked into it, found the numbers. She sent me the money, and so I went out and found in July 2003 two highly qualified ancient DNA geneticists, Ripon Molly and Jason Eshelman of Trace Genetics in California. All right? Now, these guys knew their stuff. They had worked on the Kennewick Man, and they said, we will get you an answer. We have the lab for it. We're qualified. You will be impressed. I said, okay, whatever you say. They came back shortly with the mitochondrial DNA of the adult female, which was from something called haplogroup A. It's just haplogroups are the groups that humans are divided into. And the star child's mitochondrial DNA came in haplogroup C. Up until then, we were thinking that the human found with the star child was its mother. This proved it was not, because if she was, they would have both been either haplogroup A or haplogroup C, because as I told you, the mitochondrial DNA comes down from the female line, so it's always the same. So because they had different mitochondrial DNA, they were not genetically related. That was clear. So we don't know what their relationship was, but as you'll read in the book, the woman buried it in a cave, and then she laid down beside it and committed suicide in some way. Again, I wish I had all the time in the world to tell you all this wonderful, incredible story. You're going to have to find those parts out for yourself because of the importance of what comes later. All right. So we got down to the adult female's nuclear DNA, and that recovered very easily, first attempt, and they said, get ready because the star child's probably going to be human too. But when they tried to recover its nuclear DNA in 6 attempts, they found nothing. What did that mean? If the mother's human, what does it mean when you can't recover its nuclear DNA? Father's not human. What's wrong with dad's DNA? How different is dad's DNA? That's what we had to try to determine, and there was no way to do it with primers. Understand, in 203, all there was available was primers, which were chemical strings of base pairs that were specific to humans. And if you don't know what you're looking for, you can't make a primer to fit it. So we didn't know what Dad's DNA was like. There was no way to make a primer to fit it. Again, screwed, blued, and tattooed. 204, 205, 206. The DNA coils tightened down, tightened down, tightened down. Not good years. But then in 2006, in July, 454 Life Science Technology announced it could sequence entire genomes at the nucleotide base pair level. This was exactly what we needed to recover and analyze the star child's unknown DNA. But early tests cost millions. And in 2006, we could not be certain enough about the star child's genetic heritage to convince anyone to gamble on it. Much too expensive at that point for a gamble that nobody could be sure about the result. Screwed, blued, and tattooed. 207, 208, 209, the DNA coils and twists and turns, and there's nothing we can do. We just have to sit and wait. We can't get the money. All we're doing now is we're waiting for that millions of dollar price to go down. About 208, it was $1 million or so. Here is about $500,000, $250,000. It was going down the whole time. Then, amazingly, last January 2010, a new geneticist contacted me. This photo looks remarkably like one of the rooms in the laboratory where he works. Who is our geneticist? He has degrees in chemistry, biochemistry, and genetics. He is the head of a large DNA lab that performs a wide variety of functions. His lab contracts to work mostly with viruses and bacteria because that's where the money is from Big Pharma and the National Institutes of Health. He does what he does for us on his own time, and costs come out of his own pocket. When he found out how poor I am and how bad I am at raising money, and he just, don't worry, I can do it. Okay? He works for us on weekends and holidays. His wife says he's become so dedicated to it that she hardly sees him on weekends. But she has to admit it's when he's happiest. He knows what he's working on. He knows he's making history. So he's naturally quite excited about it and bends every effort to do the best job he can do for us. He also knows his peers are going to be looking over his shoulder at everything he did. He's not a stupid man. He also knows that by doing this work, he puts his career and his livelihood on the line. If the most conservative members of his profession found out what he's doing, he'll quickly be forced out of his job and be drummed out of his profession. Naturally, this worries the heck out of his wife, but she also understands the importance of it. He is a genuine hero to me, and I'm certain that history will recognize him as such. Late February of last year, 2010, about a year ago, right now, today as I'm standing talking to you, about a year ago, I provided our geneticist with a star child bone sample. He had a valid result in March. After 11 years, the star child's nuclear DNA was finally gloriously recovered. This gel sheet shows several fragments. Right there. There it is, folks. TD. Touchdown. A DNA fragment. Now, that's all he can recover using chemicals that he does. Without a 454 machine to recover the whole genome in the way that works, you have to do it with just chemicals and different. Don't worry, it just comes out in fragments. But he pulled out a bunch, dozens of them, and we have some samples here. A DNA fragment, 265 base pairs long, proves some nuclear DNA in the star child is human. Now, how does that happen? You take the fragments and you send them to the NIH database. That's the National Institutes of Health. They pay for most of the DNA testing in this country. Most of it. Not all of it, but most of it. When they pay for it, what happens is it becomes public property. So the scientist who gets the money to do it is obligated to send that genome, that whole genome, back to the NIH database, and they're collecting. So since 2006, when these machines became available, they have collected, I think, on the order of 115 different species types. When you say a type, it's a cow or a horse or a sheep, but there are a lot of different kinds of horses and cows and sheep. So it's been thousands of different species within those species types. And we go from viruses to bacteria to sponges to mollusks, right on up to humans and everything. Everything's there. There are trillions, literally trillions, of what are called coherent base pair sequences or nucleotide sequences. You with me? If it's on Earth, for the most part, it's there. So some of the star child DNA fragments, this one 342 base pairs long, proved some human star child nuclear DNA is not human. If you look down at the bottom, it says no significant similarity found. No significant similarity found means some of the star child's nuclear DNA cannot be found in the NIH database. As I just told you, draw your own conclusions. For reasons why, it also says that, for reasons why, click here. This refers to a list of possible errors in the submission process. Our geneticist obtained the same results with multiple samples, so he has no doubt he did them correctly. Okay? So there it is. Home run, touchdown, we think. But as usual, the mainstream had an answer for us. Mainstream geneticists dismiss those results because BLAST reports, and that's what those are, BLAST can be fixed by expanding or contracting the search parameters. Unfortunately, that is true. If you want to jimmy the system going in, you can set the parameters so you'll pretty much get back the answer that you want. You can do that. Now, who in their right mind would do it? Certainly our guy didn't do it. But this was one of their ways to try to flush him out. Because when I would argue, they'd say, oh, well, tell us who he is, and then we'll just talk to him about it. And if we tell him who he is, then he's out of a job and he's gone, and we lose him. Can't afford that. So we were, another one of those real bad bumps in the road. How science dismisses problems. We've all been through this. Photographs can be faked, therefore all inconvenient photographs must be faked. Eyewitnesses can be mistaken, therefore all inconvenient eyewitnesses must be mistaken. Films of anything can be faked, therefore all inconvenient films must be faked. Physical evidence can be faked, therefore all inconvenient physical evidence must be faked. And partial DNA results can be unreliable, therefore all inconvenient partial results are unreliable. This is nature can do everything. They play hardball, these guys play hardball. It's tough. They make it tough. Anyway, so he tried other approaches. A spectrophotometer reading for human DNA and star child DNA. This is a test with fairly loose parameters. You can see that the star child is clearly human-like. It wants to be human. It's trying so hard to be human. It really is. You can see it's making a sincere, genuine effort. I want to be human. I'm almost there, but not quite. Now, an electropherogram analysis of human DNA and star child DNA. This is a test with tighter parameters. The star child clearly, this is the beginning and the end, the star child clearly is not entirely human if you go with that test. Again, it doesn't count. Not good enough. Not good enough. Now we come to the latest result. Time for some Irish foreplay. Brace yourself, Mary. All right, now again, thinking caps on. Human mitochondrial DNA contains 13 protein encoding genes and 2 RNA encoding genes. Each mitochondrial DNA has 16,569 nucleotides. It's so small, it's so precise, they really, really know about mitochondrial DNA. Here are the 2 RNA genes, and here are the 13 that are protein encoding. Now, remember when I said that the 2003 test from Trace Genetics said that the mitochondrial DNA was human and it was haplogroup C for the star child, remember? That was done with primers. Again, primers were just stretches of chemical that were human specific. So our geneticist just sort of took that as gospel. We've always took it as gospel. But I have to tell you, the whole time since 2003, when I knew that the mother of the star child was human, I kept saying from these podiums like this, but it has to be genetically engineered because it can't be a sexual union because there's nothing left of the mother. It's just all dad. And you can't get that with a hybrid in the sexual sense. It can only be that it's genetically engineered with mom being maybe 5 or 10% max and the rest being dad. And that requires genetic engineering, and that proves genetic engineering 900 years ago. And that was kind of the thing that I was pushing because there's just no other way to say it. Well, he recovered some fragments, our geneticist did, out of the mitochondrial DNA, out of the star child's mitochondrial DNA. And so he just said, well, you know, let's just take a look and see. We can't hurt anything. And that's when the fireworks started. Let me explain to you how this works. There are computer programs that compare DNA sequences. They notice variations and make adjustments. Okay, in sample 1, you see that's, in sample 2, you see TC, CT, it's pretty much the same. And then you get a difference here. You have an A where there's a C. And so you'll see that. And then as you're looking through, the rest of it right here, it starts just going wrong. C, A, C, where 2 C's where the A's are, A's and C's. It's just all messed up here. But the computer will look at that and it'll say, but wait a minute. If I skip this over 2 spaces, it catches back up again and becomes right. So it will make spaces where it finds that if it will continue on, it will work again smoothly. It knows how to do this. And sometimes it'll find spots where it's not sure. It can read that one and it's not sure about this one. It'll put an N, not sure. And when you see these reports I'm going to show you, those are the things that you'll see. This is a segment of 167 star child nucleotides on the top line. Now I'm going to show you a blow up in that blue block, so don't freak that you can't really see it very well. This is a relatively small fragment of star child DNA between, these numbers can be confusing, 1,269 and 1,426 of 16,579, excuse me, that should be 69, nucleotides in human mitochondrial DNA. It shows 17 variations. You have 12 variations here in the close-up block and 5 variations here. Okay, let's understand. This is the star child DNA here, the 147, and these two numbers, 146 and 1426 and 1269, the difference is 157. So there's 157 through here, going down to here. This is a small one and an easy one, and it comes out of the RNA. So you can get kind of a handle on what we're talking about here. That's the differences right there. I hope you're with me. This close-up view reveals the way the computer program inserts or deletes as necessary. Now again, that's this block right here, just blown up. Look at the differences. That's the 12 variations right through there. You see them? Between the star child and human in this short, brief area. Now, this you got to get a grip on. This is so cool. Human mitochondrial DNA is very highly conserved from 1,260 to 1,380. That's all we could get on this sheet and make it look halfway decent. But we can go you know, all 16,000, all up from here to here, you can see 16,000 of these things laid out in these software programs. Every single nucleotide is known and understood in the mitochondrial DNA. So this is just a little fragment. And the reason, again, is because the numbers 1269, 1426. That's it. That's a lot of that's in here. Not all of it, but a lot of it. So here we're going to look at a close-up area right there. Now, the key here to understand is that this is all of your human haplogroups right here. Human haplogroups. Human, and Neanderthal and Denisova bone and Denisova tooth down here at the bottom. You know, Neanderthal is fairly different from human. Denisova, the new creature, is even more different, and yet in this area, and in many areas, there are no differences between them and humans. There's certainly no differences in here between any humans at all. This is a highly conserved area of mitochondrial DNA. It's not that there are no changes in humans, you'll see some in a minute, but in this particular area of this particular piece of DNA that we're looking at, there are no differences at all. And here's a close-up of that, just so again you see it up close. Because DNA sequencers are so highly conserved, they mutate very little and are virtually the same for all mitochondrial DNA haplogroups. In a segment of human DNA, a fragment, that does not change in any of its many haplotypes, star-child mitochondrial DNA shows 17 variations. It is clearly not human. Now, this really is a touchdown. I hope you can see that. This is as touchdown gets. Yeah, it is. But I can assure you this will not be accepted by any of the conservative mainstream science geneticists. I don't know what they're going to come up with, but they are going to find a way to say this has to be wrong. And if nothing else, it'll be just because I won't give them the name of the geneticist so they can rout him and sack him and get rid of him as a problem. But you need to understand this is the ball game here. It really is. This is the proof we've all been waiting for. I'll show you some more. Now, there are variations in the mitochondrial DNA of human haplogroups, and they are well established in databases. All humans, all of us here, have between 10 and 66. Only 10 and 66 in all 16,000. In all 16,569 nucleotides. You with me? Now, you see that what they look like here? You have one on this haplogroup right here, has one there. The Denisova has differences here, here, here. This haplogroup has one here. This haplogroup has one here. This haplogroup has one here. You see these two red arrows? That's where we're going to look at a little box here. 1,001 star-child nucleotides in 2 fragments versus 881 human nucleotides in a gene. Okay, that number here gives you the 881, and this one together make up the 1,001. Again, we see close-up of 255 of 881 nucleotides. There are 8 deletions or insertions in between the star child, the top line, and the human. And now notice, we're not trying to sandbag you here and find just bad places. Here's a stretch where it's all the same. No changes. Just pretty much done at random, really. But we wanted to make points, and the point we want to make is that what you just are looking at right here, but the big one, covers over here. So where you have 8 variations with the star child, you only have 2 here. This one, this haplogroup, and this haplogroup. But with the star child, you have 8. Again, not human. Not human. It means its mother wasn't human. It is a pure D alien. Well, excuse me, that's a little strong. It is human-like, but it is not human. I have been cautioned by the geneticists to say, rather than say the inflammatory word alien, to to train myself to say human-like rather than alien, but it's not human. This is another random fragment. Our geneticist has dozens. In this one, 545 star-child nucleotides are compared with 562 human nucleotides in a gene. Excuse me. In this close-up, I went through 150 comparisons and quit marking at 15 variations. Several more are below the green line. You see, it becomes repetitive. Everything he threw up at me, it was again and again and again. It's overwhelming, the evidence here. But it's partial, and it's not going to be accepted because of that. But it is real, and it is legitimate. I wouldn't be here if it wasn't. Now, what does all this mean? This is going to be just some reading for a while so you can understand it. I've just thrown this together, so I normally don't like to read slides, but I can't help it. Human mitochondrial DNA has 16,569 nucleotides. I want you to listen. This is kind of like it's got to go into your heads and sink. Humans have dozens of haplotype variations in their mitochondrial DNA. All humans share between 10 and 66 variations. It is very powerfully conserved, changing very little over tens of thousands of years. The star child's mitochondrial DNA has at least 40 variations within only 5% of its 16,000 more or less nucleotides. We don't know that the star child is going to be actually the same number. We assume it's going to be in the ballpark because it's human-like, but it could be more, it could be less. This means its overall total, whatever that is, will be a staggering number. Well beyond 66. We've got like 40-something in just these three that we looked at. Understand, you're seeing the real deal here. You're in one of those history photos now. The star child's mitochondrial DNA has at least 40 variations within only 5% of its 16,000. Yeah, I just read that, I'm sorry. This tells us two things. First, the star child is distinctly human-like, which means a great deal of its genome will bear a significant resemblance to the human genome. But be aware that many other creatures also share significant percentages of the human genome. Chimps have 97 and 98%, gorillas have 95%, and the mouse, the simple mouse, has 70%. Okay? Second, because the star child's mitochondrial DNA varies so widely from normal human mitochondrial DNA, we have to conclude that its mother was not a human female. This means the mitochondrial recovered by trace genetics in 203 was only a partial result. While there is enough human-like mitochondrial DNA in the star child to respond to the primers that were available to geneticists in 2003, those primers could not and did not tell the whole story. And the reason that the nuclear DNA could not be found was that the dad's DNA was just so different, just so different. Therefore, we can now assert with absolute confidence that the star child's mitochondrial DNA is not from a human mother. Furthermore, when our geneticist is able to recover the star child's entire genome, he can prove beyond doubt that it is not entirely human. So where do we stand now? Okay, this is what we need to move forward, and I'm going to go through the amount of money we need and why we need it. It's going to be a shocking number, but bear with me and I will explain it to you in detail. And I need your help to move forward, and that's why I'm bringing you in on this. What do we need? Right now, $7 million. Now, I know. Think how I heard it when I first, how I felt when I first heard it. I know that seems like a huge sum, but it's actually, when you break it down, it's a great bargain. Everybody's cutting their prices to the bone just to get involved in this, the ones that know about it. $2 to $2.5 million for the DNA testing that must be done. This is a rock bottom price. The lab wants in on it. They know what it means. They also know what it means if it's found out what they're doing. DNA recovery, just the recovering of the genome, is the easiest part. It requires 4 to 5 months on a 454 machine and some skilled assistance. The DNA analysis, on the other hand, because so much of it is going to be different and never seen before, they're going to have to do it like they chipped out the original human genome. You might remember that took 15 years. It won't take as long now. They know how to do it much better, but it's still going to take time, 12 to 18 months and much skilled assistance. This is ancient DNA, 900 years old, heavily contaminated by bacteria, as is any bone that age or older, such as Neanderthals. It is tedious work and therefore expensive. And I just might add as an aside, the fact that our geneticist is a specialist in bacteria and viruses helps a lot because he can easily weed out the bacteria contamination when he does this work. And there's a lot of that. He says 90% of what he gets is bacterial contamination because it was buried in the ground. Anyway, 2 to 2.5 million for not one but 2 theater-quality documentary films to be developed and created by award-winning BBC producer Matt Richards, who's been wanting to do this for 3 or 4 years now. Matt's a great guy. Costs will be determined by how much of the films are interviews and how much are recreations and animations. As you know, animations can be expensive, and we need this to be absolutely one of the best documentary films ever made. Theater, that's what theater quality means. That means top flight. $2 million will finance a film company to pay the ancillary costs of producing the 2 documentaries. These will include all insurance coverage, which is always high with any film project, compensation for participants and consultants, legal fees, accounting fees, etc. This company will be required to exist for the 3 to 5 years of active life of both films. Now, what does the investor get in return? The person who puts up the $7 million, what do they get in return? 20% of the profits for both theater quality films rather than only one film. Generally, when you do a deal like this, you get the money for one. We're going to make 2, and we're going to make them for a very good price because Matt wants in on this, and everybody that he works with wants in on it. So we're getting cut rate prices everywhere. The film's distributor takes 35 to 40%. Anybody in the film business knows that's how it works. For handling all matters relating to the film's worldwide distribution. Unlike a film about George Bush, which, have we done that? Yeah, I missed it. George Bush, our 2 will be welcomed into most countries, if not all of them. I'm sorry. I've thrown this together so hurriedly, and I got 4 hours of sleep last night. I knew there were going to be glitches, and that's one of them. Anyway. They should be widely acclaimed and popular. When these films go out into the world, they will be well received in every country. That's the point I was trying to make. If both films, the remaining 40 to 45% is divided among those who played major roles during the 12 years needed to help the Star Child Skull emerge onto the world stage. That would be Ray and Melanie, that would be Belinda, and several other people. So yes, I stand to get rich, I admit it, as do the rest of those who will share in both films' profits. That seems fair. It's been 12 years and it's been 12 hellaciously hard years. If both films earn only $50 million, which I think is a conservative estimate, the investor makes $20 million for their $7 million investment. $100 million each, the investor makes $40 million. If each film approaches Fahrenheit 9/11, which is the most popular documentary yet done, at $200 million, the investor makes $80 million. Did I miss a slide here somewhere? I did. Oh, I'm sorry. I didn't do it wrong. I just forgot and went forward. The most successful documentary film so far is Michael Moore's Fahrenheit 9/11, made in 2004 about George Bush's re-election against John Kerry. By itself, one film, it cost $6 million to make. In 7 years, it has earned $225 million from 3 income streams: ticket sales in theaters, DVD rentals and downloads, and sales to network and cable TV. I am so sorry I left that out because that's just screwed this up. But I hope you're getting the idea that we are in position to compete with Fahrenheit 9/11 as the most successful documentary films ever done. The investor automatically becomes a producer of the films. If they earn any awards, such as Academy Awards, which is this week, it will be this Sunday, which seems quite possible, the investor wins one as a producer. Great wealth can buy anyone a lot of expensive baubles and toys, but an Oscar with their name on it is extremely difficult to finagle. This would be a legitimate win for that person. So it's a cool thing. An investor automatically writes their name in history books alongside mine, Ray and Melanie, and everyone else who had a major role in making disclosure finally happen. That result very handily beats blowing a similar amount on a bad drunken weekend in Vegas or Monte Carlo, or seeing it evaporate when another investment bubble bursts. Our investor has to be someone who sees the Star Child project in the way we do. They have to want to do the best that can be done with it, not earn the most from it. I don't want to be with one of these people that, want to squeeze every nickel till the buffalo poots, as we say down home. Don't want that kind of person. Whoever connects us with that person will earn a small share of the good fortune we anticipate. So whoever is the connector person is in on the deal too, for a small piece of the action, and it'll be worth your while. Why is so much needed? An important question. Why is so much needed? There is no other way to do this job. I wish there was. I wish mainstream science had lived up to its responsibilities, at least in 2006, when the 454 sequencing technology came online. But an anomaly like the Star Child is the very last thing they want to deal with, because it would upend such a large part of the world, as they insist they know it. Because of that policy, they will never accept a partial DNA recovery or analysis as a valid result. They will always find means to explain away partial recoveries as a fraud or a hoax or a mistake. Consequently, we have no choice but to overwhelm them with the entire genome, all 3 billion base pairs, all 3 billion base pairs, firmly establishing all of its variations. To establish the Star Child genome in a way that can't be disputed, every significant aspect of the recovery and analysis process must be recorded on film, must be recorded on film. Such extended, comprehensive filming is an expensive necessity, in many ways as expensive as the testing. Both testing and filming are symbiotic. Without each other, they are ineffective. Mainstream science seems monolithic and invulnerable because its most conservative members ruthlessly enforce their points of view. However, all scientists don't share those views, obviously, or I would not be here now. That monolithic facade has cracks, and we are in a perfect position to wedge them open and bring the whole thing down. We can do this. If you can help me convince an investor to put $7 million into my hands, I assure you our geneticists will initiate the age of disclosure by the end of this year, 2011, this year. He can do it. We can do it. Facts. No, we can't ask 7 million people for $1 each. I get that. Oh, well, can't you ask 7 million people? No. That would take forever and a day. We can't get, nor can we get $1 million up front and start. Doesn't work like that. Waiting for the rest downstream. The DNA lab won't begin without their estimated full fee in advance because they're not sure it could go over. We can't initiate the testing process without the filmmakers ready to begin. They go hand in hand. Got to have the filmmakers there when the geneticists are ready to go. Matt Richards will not, nor will anyone else, sign on for a 2-year, 2-film commitment without an agreed-upon fee in hand. This project simply cannot be done in stages. It's all or nothing from the beginning. The 2-year program is as follows. $7 million is invested. The $7 million is invested. We get the money. DNA testing begins. To ensure complete coverage of the genome, the DNA is put through a 454 machine 20 or more times to get all those blanks filled in so that we know we've got it all. 20 or more times. That will take 3 to 4 months. Every significant step is filmed to make the results bulletproof, and they will be bulletproof. That footage and the backstory footage are filmed simultaneously, so the first documentary reaches theaters about 1 year after the investment hits the table. Documentaries in theaters 1 year later. The second step is analyzing the results. Depending on how much of the Star Child genome is new and never seen before, analyzing will take 12 to 18 months. But it will start the 4 to 5 months after when they have the recovery, it'll start right in with the analyzing. So that'll be going on while the first film is being cut and edited and put in theaters. So, where am I? That will be film 2, as well as, and the second film will be that, the analysis, as well as interviews with famous and not so famous people, asking them how they feel about the disclosure of alien reality occurring at least once at 900 years ago. The second film will reach theaters several months after the end of the analysis. We feel it will be roughly 1 year after the first film is in theaters. The timing just works out this way. Thus, a 2-year plan. We're not infallible, but we've worked on this project for 12 years, and coincidentally, I worked in Hollywood for most of the 1980s as a screenwriter, and so I know a little bit about this business and how it works. So we've had plenty of time to consider the best ways to go about it while avoiding pitfalls. We feel ready. We feel really ready to do this. We've been planning it for a long time now. Summary, last slide. We know without any doubt that the Star Child's DNA is not entirely human. It will take a decade or more to chip out its genome piece by piece by piece. It will take only a few months to recover the full genome using 454 technology. The geneticist has done all that he can do to get things to this point. Anything he does from here on is basically repeating himself. He needs to move forward, and so do we. You've seen it. There's really no more to do at the fragment level. There is no more to do. I can't raise dust on a dirt farm, I admit it. I am just the world's worst when it comes to raising money. I just don't have a knack for it. I don't know why. So I must have help to find an appropriate investor. I don't move in wealthy circles, and the kind of people we need are the kind who will pay assistants good money to keep people like me away from their bosses. That's one of the reasons I can't do it. Don't tell me, give it to Bill Gates, tell Bill Gates about it. Well, how do you get to Bill Gates? It takes some kind of personal connection to a wealthy individual to get past their gatekeepers. It just does. Somebody has to know somebody. Not each of you, obviously, but surely some of you have the ability to play a major role in securing our investor. Do you personally know the kind of wealthy individual who might be interested in what we have to offer? If so, please let them know about it. And if they're interested, of course, have them contact me. I'm very easy to find, lloydpye.com, or lloydpye@gmail.com. The bottom line is that money talks, BS walks, and small change rides the bus. Only action counts. If you can help us make this happen, please do it. I need help, but as you can see, I hope we are poised on the edge as I began this thing of making history as big as history can be made. I hope that I've got that across to you in the way that I hoped that I would be able to do it. This again, I want to say again, this has been a very rushed, hectic time for me. I began the process of learning this information, most of it Friday night, the 12-year anniversary. I can't tell you how difficult it was to try to assimilate it and to regurgitate it out in a way that you would understand it. I got home late Sunday night. I worked all day Monday, all day Tuesday, as much as I could yesterday and last night. Got 4 hours of sleep and all this morning. I went over every slide about 20 times. I'm tired. My brain is fuzzed. I apologize for those mistakes. But I hope that you can feel the passion and the sincerity with which I've brought this message to you. You were all sitting in the meeting where Roosevelt was reading the letter. You were all sitting in Congress when Kennedy was issuing the call to land on the moon. You were all sitting in the Xerox boardroom when they were making the decision to start Park. You are there. You are participating in a pivotal moment in history, whether you realize it or not. Thank you very much.